Okay, guys, we're going to go ahead and start electrochem. Some of this does come over from chapter 8 when we did redox reactions. So we're going to kind of start with that. This is going to consist of 3 different videos for chapter 19. And basically today's will be review. All right, so hopefully you remember some about redox reactions. Remember that's when electrons are being transferred between different atoms or ions, and you have to have both to happen in a full reaction. Down here at the bottom, we do have these half reactions, and we're going to be dealing with those a lot this chapter. But in order to be a full reaction, you have to have both to be redox. Some things I need you to remember are these acronyms. Leo says GER. Okay, Leo stands for loss of electrons as oxidation. And if you look down here at the bottom, when the electrons are coming out of the reaction, it lost them. And then the GER is gain of electrons as reduction, and those are going into the reaction. So also for oxidation, remember that means the oxidation number is going to increase, and for reduction, that oxidation number is going to decrease. And I'm going to go ahead and real quickly go through oxidation numbers so we remember. I meant to put that here. We'll come back. So oxidation numbers or oxidation states, those are very similar to the charges on the periodic table, even though they're not exactly the same. These are just imaginary numbers that we're assigning to them based on rules. Okay, so here are the rules. All free elements are 0. So if it is an element by itself and there's no other element attached to it that's different, so like Cl2 is 0. S8 is 0. Everything that's a single element is 0. One that's got a charge, if it has a charge, it's going to be whatever charge it has. So like if it says Na+, it's +1. If it says Cl-, it's -1. And then the sum needs to be equal to 0 of a compound unless it shows a charge. That's 3b. Okay, so polyatomic ions, they have a charge. The sum will be equal to their charge. Rule 4 is that all group 1 metals keep their charge and all group 2 metals keep their charge. And this is an always situation. All right, number 5 is in order of, like it's a hierarchy, okay? So nonmetals that are higher on this table over here are going to take priority. But the main thing you need to remember is hydrogen is usually +1. Oxygen is usually -2. And then all the halogens, group 6A and group 5A, usually keep their charge unless there's an oxygen or a hydrogen to take priority. Okay, so we're going to go through some practice just to refresh your memory. Remember, all free elements are 0. Monoatomic charges are whatever charge they show. For C, now we're to a compound. Remember, the sum must be 0. But if you remember, K is +1 because that's a group 1 element. And fluorine is -1, although that's a usually situation, but for that to equal 0, that's what we need it to be. For D, we've got CO2. Carbon's column does not have a rule, but oxygen does. So what we do is we set this equal to 0, the sum of it. And we're going to solve for X, which is carbon. I put this first 2 outside of it because there are 2 oxygens. So if I solve for this, that means carbon is +4. And then oxygen is not plus, -2. Okay. For E, again, we're going to have to set it equal to the sum. And this one does have this -2 charge. So we're looking at X because I do not know sulfur. And I've got 4 oxygens. But this time it's equal to -2 because we show a charge. So if we see here, sulfur is going to be +6. Oxygen is going to be -2. And then for potassium peroxide, and I do apologize, my husband's about to walk in, so it may get a little loud. I'm hoping he's quiet and realizes I'm recording. All right, so oxygen does not take priority because oxygen's rule is in rule number 5. Potassium's rule is in rule number 4. Okay. So I've got 2 plus 1s plus 2x, because I don't know what that is equal to 0 because that rule does not take priority for oxygen. So now we need to solve for oxygen, and in this case, oxygen is going to be -1. A peroxide is the only time oxygen is not -2. All right, so if you need more practice, there's some more practice, but we're going to keep going through these, so you're going to get practice as we go along, okay? Let's just real briefly, sorry, it's kind of out of order. We need to go talk about oxidation versus reduction. So once you find your oxidation numbers, which is super important, so please, 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 if you need help, reach out. You look at what happened. So this chlorine went from 0 to -1. So because it changed and went down in oxidation state, it was a reduction. And then our iodine went from -1 to +5. So it went up significantly, and so that one is oxidation. And the half reactions, again, you can see it more easily with the electrons shown, but you can also do it with just the oxidation states. Okay. So now we are to balancing redox reactions. So you will get them and you'll have to separate them into half reactions, and there's a process, and then we will put them back together at the end. All right, so yes, this is a lot, and yes, you're going to need to know how to do this because there's going to be at least one question on your final that covers this. All right, but I'm going to go ahead and walk through them with you so you can see them, because without any meaning, they don't really mean a whole lot. Also, number 1, assigning the oxidation states, you don't necessarily have to do that as long as you understand how to break them into half reactions. All right, so here's one. Notice this says acidic solution, and just remember that means an H+, because that's what an acid is. So we are looking at aluminum solid. I'm not even going to deal with the states. Goes to aluminum 3+. And then we've got copper 2+ going to copper. All right, so the first step, once we've got our half reactions, and the way to know which ones are together, don't pay attention to oxygen or hydrogen, but everything else just keep together. So aluminum's going to go to aluminum and copper is going to go to copper. If there were oxygens that were attached to them, they just stay attached, and you're going to see that in the next explanation or example. So once we do that, split them, we're going to balance the elements other than hydrogen and oxygen. So I've got 1 aluminum on the reactants, 1 aluminum on the products, we're good. Same thing with copper. So then we do hydrogen and oxygen, but there's not any in this equation. So then we do charges, because everything must be balanced, not just the elements now, okay? So I've got a 0 charge on the aluminum, and I've got a 3+ charge. So I need to add electrons to the side that has more charge. And I need to bring them down to be equal to each other. So I'm going to go ahead and add 3 electrons to my product side. I need to do the same thing for copper. I've got 2 charge and 0, so I'm going to need to add 2 electrons. Okay, so once I've done that, I need to be able to put them back together. The electrons have to be the same. So if they're not the same, I do need to go ahead and multiply that whole half reaction to get them equal. So I got them both equal to 6. When they are equal, you can cross them out, and I'm just going to go ahead and add these back together. So 2 aluminums plus 3 copper 2+ ions. It's going to make 2 aluminum 3+ ions plus 3 coppers. Okay, and then it's balanced. I do want to go ahead and walk through one that's different. So here we've got hydrogen, but still no oxygen. Let me see. This one has oxygen. That's what I wanted. All right, so this one is basic solution. This means if I have anything left over, I'm going to have hydroxide left over. All right, so again, step 1, break up. So iodine ion is going to go to I2. Permanganate is going to go to manganese dioxide. All right, so again, remember we're going to balance elements other than oxygen and hydrogen first. So the first thing I notice is that iodine is not equal on two sides, and to make it equal, I need to place a 2 here. Remember, the only thing you can add when balancing are coefficients. Okay, manganese is good. Next, we look at oxygen. Sorry, to balance out oxygen, we need to add water. So I've got 4 oxygens here and only 2 here. If I add 2 waters to this, I've got enough oxygens in my product side. The reason we can add water is because in the original reaction, they say aqueous. So water's in there, we're just adding it into the reaction to balance it out. Okay, it's not that we're just adding in, pulling things from nowhere. I added this because it's aqueous. All right, so then once we have that, the waters, now I've got these hydrogens over there that I need to account for. So you add H plus to account for your hydrogens. So I had 4 hydrogens that I added because of the water on the product side. So now I have to add 4 H pluses to the reactant side. Now, once all of my elements are equal, I need to balance my charge. So I've got 2 minus on my iodine ion side and 0. So I need to add 2 electrons over here to get it down to 0. On my manganese equation, I've got 3 charge plus 3 on my reactant side and 0 on my product side. So I need to add 3 electrons on this side. Y'all, one thing I really want to stress at this point is if you do not have electrons on different sides, something's wrong because they have to cross out. And they do not cross out if they're on the same side. Okay, here we go. We do need to add them together once we have equal number of electrons to cancel. So I've got, 6I minus plus 8 hydrogens plus 2 permanganate plus yields 3 iodines plus 2 manganese dioxide plus 2 waters. Okay, at this point, if things cancel, go ahead and cross them out, but there is nothing that cancels yet. If this was an acidic solution, this is where we would stop because of this 8H plus. But this one says basic. So we do need to add base in there so it becomes a basic solution instead of this acidic solution. So for every H plus you have to add OH to both sides. So I'm going to add OH here, 8 of them. And I'm going to add 8 OH on this side. Once you do that, the side that has the hydrogen, these come together and make 8 waters. Okay, when that happens, now we've got waters on both sides normally, so we need to go ahead and cross them out. So these are going to completely cancel on our product side, and this one's going to become a 6. So this is kind of a mess. I do want to clean this up and then recheck my charges. So I have 6I minus plus 6 waters plus 2 permanganates. And that makes 3 iodines plus 2 manganese dioxide plus 8 hydroxides left over. All right, so now we're going to check our charges because it's super important that we check our charges at the end, because if charges aren't balanced, then neither is our reaction. All right, so I have 6 iodines plus 2 permanganates. This is an 8 negative charge. And on this side, I have 8 negative. One thing you do need to keep in mind with this is that it is, if no charge is shown, it's neutral, which is what most compounds are. So I just need you to keep that in mind. No charge shown means 0. Okay, here's another one to work through. I'll go ahead and work this one because I know this is a little harder of a concept. And I know in this for practice, that looks like a CI. And I don't know why they like to do that, but it was a picture, so I couldn't change it. That is Cl. So I'm going to do it up here. ClO minus goes to Cl, and then CrOH4 minus goes to CrO4 2 minus. All right, chlorines are balanced. Chromiums are balanced. Now we add waters for oxygen. I need 1 water for chlorine. And I need no waters for my chromiums because I've got 4 oxygens in my CrOH4 minus, and I've got 4 in my CrO4 2 minus. Now I balance hydrogens. I need 2 hydrogens on this side. And on my other one, I need 4 on that side to balance. Now we do our charges. I've got a +1 charge for chlorine versus a minus charge. So I've got to do 2 electrons over here. My chromium, I've got a -4 and a +2. So this side needs 3 electrons. All right, so once I do that, we do our balancing them. Sorry, that one's by 3. This one's by 2. I am going to go ahead and write this at the bottom now so we can get more space once it's all together. So I've got, and remember the electrons cancel. That was the whole reason we did that. 6 hydrogens plus 3 hypochlorite plus 2 CrOH4 minus yields 3 Cl minus plus 3 water plus 2 chromate plus 8 hydrogens. All right, once we do that, remember, cross out what's on both sides. The only thing I see on both sides are hydrogens. And because I got rid of 6, this is 8's going to go down to a 2. This one does say in basic solution, so I need to add 2 hydroxides. These become 2 waters. So I know this looks like a mess right now, but my final answer, because I've got 2 waters and 3 waters, I've got 2 OH minus plus 3 ClO minus plus 2 CrOH4 minus yields 3 Cl minus plus 5 waters now plus 2 chromates. Okay, at the end, remember you need to check your charge. I don't want y'all to think, let me write that up. Okay, that doesn't belong to us. All right, so that final bottom piece is what we're looking at for charges. I've got -2 plus -3 is -5 plus -2 is -7. And then I've got -3 plus 2 times -2 is -4, so that's -7. Again, you have to make sure they match up, otherwise it doesn't work out. Okay, this is where we're going to go ahead and stop today. We'll pick up on electrochemistry next time. Y'all have a great day.